Okay, on 6 it says find the simplified quotient and domain of. So the last one said find the quotient. It didn't say domain, but there's an implied find the domain every time anyway. This one's written as a quotient, right? So this divided by this. So it's already written in division form. So once again, if I'm looking at this problem, I see division of a fraction, I want to change the multiplication of its reciprocal. So I want to flip that second fraction over, change it to a multiplication problem. So as I copy it from my book onto my paper, maybe I'm going to do that right away. So 1 over x squared plus 9x. I'm going to do times. And I'm going to put the bottom on the top, so that's 3x squared minus 18x, and then 6 minus x on the bottom. So, once I've written the problem like it's supposed to be written, which is this, times a fraction instead of divided by a fraction, flipping the second fraction over to make a reciprocal. Now I'm looking to factor whatever I can factor. So I've got a binomial here, looks like a common factor of x is possible there. I've got a binomial here, common factor of 3x is going on there. Got a binomial here with, looks like no way to reduce it. So, and then 1 just 1, so nothing happens to it. So I got 1 over. Okay, always look for greatest common factors as a factoring step. The last problem didn't have any, but this problem, x squared plus 9x, x is common. X plus 9 is what's left over when you divide by the common factor. That's all greatest common factor is or ever will be. Something divides evenly into both objects, you write it down, then divide both objects by it. The number 3 divides both numbers in the top here, so 3 is a common factor, x is in both objects, so x is a common factor, 3x is the greatest common factor, we divide by 3x, 3x squared divided by 3x is x, negative 18x divided by 3x is negative 6. Now looking at the bottom of that 6 minus x, can we all see that 6 minus x does not factor, right? Right? But can everybody also see that x minus 6 is up on top here? So if this said x minus 6, it would make it better, right? Yeah. So I'm going to go ahead and write that as x minus 6, but to allow me to do that, I have to factor negative 1 out of it. That's a pretty typical occurrence. It happens frequently enough that it should just be second nature to you. Hey, look, everything's what it should be except it's backwards. The signs don't match. So make x positive, make 6 negative. That requires a negative 1 to be taken out. Right, that should just be just something you were able to do whenever you feel like doing it. Now, looking at canceling, we're looking for common factors. Everything being multiplied as a factor, and sometimes people get a little hung up on this. Let me just point this out. 3 all by itself is a factor. It's being multiplied by x all by itself is a factor. It's being multiplied by x minus 6 is a factor. Okay, so even though we took 3x out together, the 3 all by itself is a factor, the x all by itself is a factor. So when I see on the bottom here that there's an x here to go with the x there, those x's are exactly the same, they cancel. This binomial x minus 6 matches this binomial x minus 6, they cancel. Okay. Nothing else cancels. Even though this 3 and this 9 both divide by 3, this 9 is attached to this x. So when things are added together like that, they're treated as one object. They have to match another exact object like that. So what's left on top out of all that stuff is just 3. What's left on the bottom is x plus 9 and negative 1. And if I multiply negative 1 times x plus 9, it multiplies by both pieces. So negative 1 times x is negative x. Negative 1 times 9 is negative 9. So this is the correct answer. As for domain, anything that made the top or the bottom of either one of these things equal, top or bottom of this or the bottom of this equal to 0. So again, both the top and the bottom of the thing being divided and just the bottom of the first one. So x equals 0, x equals negative 9, x equals 6, x equals 6, x equals 0. And each factor, just look and say what makes it 0. X equals 0, negative 9 plus 9 makes 0, 6 minus 6 makes 0, 6 minus 6 makes 0, 0 makes 0. So the numbers x is not allowed to be would be 0, 6, and negative 9. One other option for the right answer, just while I'm thinking about it, the minus sign could be on the bottom or the top, doesn't matter. So if I put the negative 1 on top, negative 1 times 3 is negative 3 over x plus 9. That's also correct. Take your pick on which one you like better. But again, either one of these answers is right. I probably would have gone with that one because that's where it was located, but if you wrote that, you're not wrong. Did you say something?
Why isn't one of the things x can't be?
If x equals 1, so again, we're not allowed to have anything on the bottom equal to 0, right? So if x equals 1, 1 is 1, not 0. 3 times 1 is 3, minus 18 is negative 15, not 0. 6 minus 1 is 5, not 0. 1 plus 9 would be 10, not 0. Any value that we put in here over here, if I put 0 in, 0 plus 0 is 0, and the bottom is 0. If I put negative 9 in, negative 9 squared is 81, minus 81 makes 0. If I put 6 in, 6 minus 6 is 0. 6 times, that's 36 times 3 is 108, 18 times 6, 108, 108 minus 108 is 0. So the numbers that we're saying x can't equal would be what will make these things equal 0. The number 1 itself, first of all, it's on top of the first fraction, so it's not going to factor into the whole domain issue, just what was on the bottom at any point in the problem, which would be these three things. And then even if it were on the bottom, 1 can't equal 0. Only when you see an x in the problem do you consider that could possibly equal 0 because it's a variable. 1 equals 1, so it's always not equal to 0. So factors that are whole numbers, they don't factor into the whole. We'll just make 0 happen. Okay? Any other issues for anybody?